All right, let's do one more example where we're finding the derivative of some inverse function. So suppose we want to find the derivative of arc cosine of x, otherwise known as cosine inverse of x. Right? That means that the original function f of x would have been cosine of x. And we know that the derivative of cosine is going to be negative sine of x. And our inverse function, right, the thing that we're interested in is arc cosine of x. I usually like to write this here just as a reminder, in particular because we end up having that term in the denominator that's f prime of f inverse of x. So I like having this here as a reminder, like, okay, I'm doing f prime, which looks like negative sine of something. What is that something? It's whatever f inverse is. Right, so this is going to end up being our denominator for the derivative. Okay, so let's go find that derivative. d dx, remember this just means the derivative with respect to x of blank. So what is it that we're taking the derivative of? Arc cosine x. And using our derivatives of inverse functions, that general formula, right? These have all looked the same. It's 1 over, well, we already did some of the work, right? F prime of f inverse of x. So we did some of the work here. Negative sine of arc cosine of x. And we have to tweak this a little bit. I mean, we don't have to. It's fine here, but it's not very useful in this form. So we're going to bring in our Pythagorean identity that says that sine squared x plus cosine squared x equals 1. Right? And these x's could be anything as long as they're the same. So we could say sine squared of 3x plus cosine squared of 3x equals 1. So as long as those two line up, we're in good shape. So let's replace some of our stuff here. So we go, well, I don't have a sine squared. I just have a sine. Right? So I can manipulate this a little bit and just say, cool, let me take that Pythagorean identity. First, I'll get sine squared by itself, so 1 minus cosine squared. And then we can take the square root. So sine of x is the square root of 1 minus cosine squared. So from there, I'm just going to box that off. From there, we can replace this a little bit and say, okay, we've got 1 over, well, we have a negative here that doesn't really show up here. So why don't we just toss that negative on top, right? It's totally fine to put it there. And now we're going to replace sine of some stuff using this. So sine of, well, not x, but arc cosine of x, right? So if I see an x here, I've got to replace it also with arc cosine of x. So it's going to be the square root of 1 minus cosine squared of, well, not x like the generic formula, but arc cosine of x. Extend those out. And then we go, okay, well, cosine of arc cosine of x. Those two, again, those were the function and the inverse that we started with. So those two should give us just an x, and that's getting squared. Right? So this looks like negative 1 over the square root of 1 minus x squared. Right? And just for clarity, just to kind of reiterate what I said, right? Cosine of arc cosine of x is x. We needed that little piece to sort of clean up what was going on inside the square root there. Right? The only other thing we should keep in mind as we're doing this is that arc cosine of x, just like arc sine of x, they have sort of a limited range coming out of them. So we have to be sort of mindful about where this is actually defined for what values of x. That's a little bit technical for right now. I just want us to see kind of generally what these derivatives look like.